Hi there, I'm Dr. Corey Priest with in2GREAT. I'm actually sitting at home right now. Thought I'd take a minute to record a video, explain a little bit about this whole viral thing and a test that's coming out next week. I am limited to the knowledge that we have of this whole pandemic and the COVID virus and stuff up to this point of April of 2020. Just wanted to throw that out there. So first I want to address what is a virus in the first place. Hopefully a rudimentary education on what a virus is can help you guys understand a little bit about how the immune system works, and maybe dispel some myths for you as well. But a virus is not living. A virus is not a bacteria, it's not a fungus, it's not a yeast, it's not a parasite, so it's non-living tissue. It's actually genetic tissue. It's a genetic material that has the ability to get into the system, float around, affect a cell, and once it infects a cell, that's when it goes to work. That's when the virus will actually start mutating the DNA, it'll start mutating the internal mechanisms and mechanics of the cell and start replicating, and that's when things can go south really quick. Now, I want to tell you the best defense against a virus is a healthy immune system, period. And I want you to understand that. That's what I've been saying from day one, and that's what I'm going to continue to say, especially as we are reintroduced into society together. It's going to be very important. Those of us that have the strongest immune system are going to be the most protected and get through this really easily. With that being said, I want to explain a little bit about the body's immune system and how it works. So I'm going to talk about innate immunity and adaptive immunity. Innate immunity, think of that as the bouncer at a bar or office building security management system. It's cells that are literally floating around, scavenging, looking for foreign invaders. Probably one of the most well-known and best defense mechanisms within the innate immune system is a natural killer cell. It has two programs, and those two programs are to kill and not to kill. And so as it's scavenging, it's communicating with every cell that it comes in contact with to understand, is this my body's natural or my body's natural cell, which I don't need to kill that, or is this a cell that has a foreign protein or carbohydrate attached to it, at which point I need to kill it. And so it's going to kill it by telling that cell to either commit suicide, or it's going to kill it by injecting a bunch of enzymes and things to destroy it. Okay? But as it's doing that, what's happening within that innate immune response, it's activating the adaptive immune system. And think of the adaptive immune system as a special ops team that's going in and doing an undercover special ops mission or something like that. It's very targeted and very specific, and it's got one mission, and that's to destroy that current infection. Okay? So the adaptive immune system is triggered by the innate immune system, but then that's where B lymphocytes, a cell called a B lymphocyte, comes into play. And it's producing a bunch of antibodies. And that's where I want to get into the type of testing that we're going to be looking to is antibody testing. But before I get into that, I want to give a brief summary of some of the symptoms that are going on with this infection. Because most of us think it's just upper respiratory stuff, but it's a little bit more comprehensive than that. So the symptoms currently that we're identifying as time has gone on and more infections have occurred and we've learned more about it are the coughing, the fever, the body aches, sore throat, fatigue, headaches, and some other big common ones are GI irritation, like diarrhea, abdominal cramps, pains, that type of stuff. And why that is because of how this virus and the areas it likes to infect. But I say all that because we're also in cold season, we're also in allergy season. So a lot of people are confusing those symptoms with, oh my gosh, I have SARS-CoV-2. Well, that's not necessarily the case. And this is where testing, and especially the antibody testing that we have available coming next week, is so critically important for people to understand what they have and don't have. And we can make better decisions with that information. The current standard of testing right now that you've been hearing so much about is the nasopharyngeal swab. It's where they actually stick this thing up your nose and they start swabbing around, trying to look and try to capture actual genetic material of the SARS-CoV-2 or COVID-19 virus. Okay? There's problems with this. Even though it's a standard of care, the problems with it are it's invasive, It's expensive. There's a lot of false negatives. It's dependent on the sample that's taken. It's a very laborious process. There's a lot of false negatives too, which is a very big problem. So while it's the standard of care, it's not necessarily the most ideal test. Versus antibody testing, which is where we're actually looking at to see how your immune system is responding. We're looking at how your body's staging it and where you at in the response to the virus. So the antibody testing actually gives us a whole bunch more information. It just doesn't tell us is there a presence of the virus or not. It does not tell us that. I'm going to digress for just a second to explain to you the different types of antibodies. But before I do that, I need to explain to you the difference between an antigen and an antibody for those that don't know. So an antigen is the bad guy. It's the foreign invader. It's the virus. It's the cancer cell. It's the bacteria. It's the protozoan. It's the bad guy. An antibody is your body's immune tag to initiate a more special immune response, as well as trying to cause the infection to become, I guess, less inactive or less infectious, if you will. So what will happen is once that natural killer cell is doing its thing, it's telling the B lymphocytes over here, hey, you need to start prepping yourselves and start replicating, becoming active to produce antibodies to go after this infection. And so the first antibody that's produced by the immature B lymphocytes is IgM. And IgM is produced within about 0 to 5 days, so right upon infection to up to maybe 5 days, maybe 7 days. But generally it's really quick. And so when you do IgM testing, you're able to see, is there an active acute infection occurring? And what'll happen is that IgM will start coating those cells, so that those infected cells, so that they can't continue to infect other cells, and it stops the replication process is what it's trying to do. Okay. Then what happens as that B lymphocyte starts to mature and understand what it's dealing with more, it'll start producing something called the IgG antibody. And an IgG antibody is a lot longer lived. It'll live for about 30 days or so. And what occurs at that point is now that IgG antibody is also coating the cell even further, but it's also triggering and binding to macrophages, which is your Pac-Mans. It's also binding to natural killer cells and other types of white blood cells. So they're very targeted to go after that specific virus or bacteria, whatever the infection is. And then what's also happening is if the infection gets into the mucosal linings, then you start producing something called IgA. And IgA is the next phase of protection to help the actual tissue from getting infected. So IgM and IgG are more bloodborne, and then the IgA is more within the tissue. About 80% of the antibodies within the tissue is IgA. So what will occur is then, think of IgA as your bouncer within the tissue. And so the IgA is actually coating it within that tissue so it can't infect more components of that tissue. So IgA is heavy in the mucosal linings, the mouth, the nose, the throat, the lungs, the GI tract. And so this is why this COVID-19 or SARS-CoV-2 virus is affecting the GI tract, because it likes to bind and attach to these mucosal linings and cause a huge inflammatory response, which is where people who are immune compromised struggle so much to overcome that initial inflammatory response, and it just takes over. So with that being said, that's the different types of antibodies. And the reason that's important that I explain that to you is because most labs out there that are testing the antibodies is they're just looking at one single antigen, and they're looking at maybe 1 or 2 antibodies. And so it's not a complete test. So what we've decided to do is we've decided to use Vibrant Wellness and partner with them in using the test to provide to our patients and individuals that want to get tested, because they're looking at a whole litany of things to give us a whole bunch more, I guess, specificity would be the word. And so what we're looking at, this document here that I have will be actually put attached to the link that we're sending. And so what I want to point out to you is on this document, it'll show currently what they're offering, the 4 different antigens right here that are being tested. And then within these 4 different antigens, there's 3 antibodies being tested for each antigen. So there's an IgG, an IgA, and an IgM being tested for each one of these antigens. So what specifically are these antigens that are being tested for, you might ask? So this is the CoV-2, the SARS-CoV-2 virus, is what it looks like. And what you see here is the internal workings of the viral replication code, and then the wall of it. And so these big spikes here that you see are what's called spike glycoproteins. So you have a spike glycoprotein 1, or an S1, and an S2. And so this test, this vibrant wellness test that we're going to be using, actually is looking for IgM, IgG, and IgA antibodies towards spike 1 as well as spike 2. And then what they do is they go and they start looking at the nucleopeptide. So you look at the internal antibody production towards the nucleus of this virus. And so again, we're looking at IgM, IgG, and IgA for that as well. And then there's a receptor binding protein a little deeper here that you might see, and that's another thing that they're looking at. There's a couple other antigens that they're talking about adding in the upcoming weeks to help improve this. So why is that important? Because if you're running a test that is only looking at a single antigen, but that tests negative, but you have other antigens that are testing positive, you're going to get a false negative. And so even though that test might be highly specific for just a single antigen, it's not very sensitive to the SARS-CoV-2. And so the more antigens you can look at towards a specific infection, a microbe or virus, the more sensitive you are to and specific you are to that specific infection. So this test is the only test that I know of right now that is able to help us with high level of specificity and sensitivity, close to 100%. It's around 97% sensitive and about 99% specific to COVID-19. And it'll allow us to see the staging process of this, because we get a positive, negative to each one of the different antigens and different antibodies. They're also working on getting a quantitative mechanism to this so that we can actually see how much, so we can actually trend and see where you're at in the process of overcoming this. So I'm really excited to let you guys know that we're actually offering a very sophisticated test to give us the best information we have at the moment, better than any other test that's out there. And it's going to be available come this next week on Monday or Tuesday of this coming week. The only downside to this test is going to be with any antibody test is if you aren't producing enough immunoglobulins, then it might give us a false negative. So that's why we are deciding to take this one step further and add in a total IgG and a total IgM so that we can see if you're producing enough antibodies for this to be a valid test for us. So it just gives us a better understanding how your immune system's working. And the only other problem with this test, if you're on any type of immune suppressant like Humira or prednisone or corticosteroid of some sort, it's probably not going to be a good test for you, because that's going to suppress your immune system. But other than that, this is a legitimate test to consider if you want to find out if you've been exposed, if you're fighting, or if you have some immunity towards this COVID-19 virus. And again, I want to end by saying, even if you do have the infection or you're fighting it, the most important thing is to make sure your immune system is strong, and that's what we can help you do. So I hope this was helpful. Let us know if you want to get tested. And it's a pretty simple blood draw test is all it is. We'll have results within about 24, 48 hours, so it's a quick turnaround time. I do want to make sure that I review each of these results with a patient and not just give you the results, so that you have a full understanding of what this is telling you versus you trying to interpret and understand what this is and have some false information. So with that being said, give us a call so that we can actually get you tested and get results back to you as quick as we can. And we'll go from there. Talk to you later. Bye.